Hi everyone. All right, this video we're going to go over the solution of sample exam number 4B. Okay, there's some conceptual questions in the beginning, the first five problems. These are just questions. So the solutions are already there. You can find them here, or if we start the solution, it's right here. So please read those. I went over this when I was lecturing about those topics. So I let you kind of review those, read them, and it's about requirements of the testing and some other conceptual questions. So please read those. I won't go over this in this video, but I want to go directly to the calculations. So let's start with the first one, which is number 6. It says use a chi-square test to test the claim that in a given contingency table, again, remember contingency tables, the row variables and the column variables are independent. So this is a contingency table test and test of independence. Let's see what it says. Test for adverse reactions to a new drug yielded the results given in the table. At a 0.05 significance level, test the claim that the treatment, drug, or placebo is independent of the reaction, whether or not headache were experienced. So this is a two-way table. You have headache, no headache, drug, with drug, having a headache, and with drug not having a headache. It's here 73. Placebo, that means it's not a drug, it could be anything, just water, and but the patients are not aware of that. Headache is 7 and no headache is 91. So basically we want to know if the drug and the headache are dependent or independent. Now for this type of test of independence, remember if you watch the video, the lecture I gave about the contingency table, HO is always independent and H1 is dependent. I just put independent and dependent just for you to remember. Independent for HO all the time and dependent for H1 all the time. Now, if you read the solution here, it says the treatment and reaction are independent for HO. Treatment and reaction are dependent. So I just wrote independent and dependent. Now, contingency tables, we always deal with right tail chi-square test. So let's start the test. So once you write the claim, then you find the degrees of freedom. The degrees of freedom is number of rows minus 1 times the number of columns on minus 1. Number of rows, you have 2 rows and you have 2 columns. So 2 minus 1 times 2 minus 1 is 1. And let's go. Then you want to find the critical value. So let me go over that. Chi-squared right tail test. So you have to find that by using the chi-square table. So if you go to chi-square table, 0.05 degrees of freedom 1, you're going to see it's 3.8841. So, and here I have part of the table here for the second column, but we can kind of take a look at it. So 0.05 degrees of freedom 1. So if you go to 0.05 degrees of freedom 1, we get this number 3.841. So there we go, 3.841. Then you have to find the test statistics. The test statistics, we said it's the sum of O minus E squared divided by E. O is whatever is given in the table. Those values are the observed values. And E, you have to find them by using row sum times column sum divided by the grand total. So you have to do that for each one of them. Please take a look at the example of the lecture. You can do that if you want to. then use this formula and add them. So then that's going to give you the test statistics. However, we can do this with our calculator, and I will share the calculator with you so you see how this works. So contingency tables, we always have to go to matrices. Let me stop sharing that and share the calculator. So let me clear everything. Now, for contingency tables, we have to go to the matrix. So you do second function x to the power of -1, because on top of that, you see it says matrix. So bring the matrix out, go to edit, and just pick the first matrix and look at the table. The table has 2 rows and 2 columns. So it's 2 by 2 basically. It's the same thing. If it's not, just put 2 by 2. So put 2 by 2. I'm just redoing. And start putting the numbers. And I have those numbers here for you. So it's 11, 7, 73, 91. If you take a look at the problem, you'll see those numbers. Once you make your matrix, then go to stat and go to test. Scroll down until you find let's see, chi-square test. Don't go to GOF. This is goodness of fit. We're going to see that right away. So just chi-square test and enter. You don't have to do anything else with, if you use your calculators, you don't have to calculate the expected values. Calculator does everything, and just calculate. Calculator will give you the test statistics and the p-value. And of course, the degrees of freedom here, it's 1. So let's go and make the conclusion. So here, that's what we got from the calculator. And again, I put all the steps for you. So follow these steps, second function, then you go to matrix, edit, pick 2 by 2 matrix, enter the data, go to stat again, test, go to see chi-square test, and get the critical value, which is 1.798. So that's in the non-shaded region. First conclusion, failed to reject HO. Failed to reject, that means accept HO or reject H1. Accept the fact that they are independent, so you can say they are independent. So let's read the solution. So we have the failed to reject the null hypothesis. We did that. There is not enough sufficient evidence to warrant the rejection of the claim that the treatment and reaction are independent. So we don't have enough evidence to reject it, but what we said, we accept it. So we basically, it's the same conclusion. Number 7, 160 students who are majoring in either math or English were asked a test question, and the researcher recorded whether they answered the question correctly. The sample results are given below. At 0.1 significance level, test claim that response and major are independent. So here again, you can put response and major are independent for H, or response and major are dependent for H1. But I just put independent and dependence for you to remember. Same thing, you write this again, it's a chi-squared left right tail test. So degrees of freedom, row -1, number of rows -1 times number of columns -1. If you do that, you get 1 again. Right tail test, don't divide alpha by 2, just go to 0.01, degrees of freedom 1, and you get 2.706. So that's our critical value. And you can find this is the solution, but same way, you can go for the calculator, you go to second function matrix, that's on top of x to the power of -1. Then you scroll to edit, pick 2 by 2. This is again a 2 by 2 table or matrix. Enter the data, go to stat, pick test, then go to see chi-square test, and you get 6.502. 6.502 here is after 2.706, so it's in the shaded area. Therefore, first conclusion, reject HO. We are rejecting that they are independent. So you can write they are dependent, or you can read the solution which says the same thing. Number 8, use the sample data below to test whether car color affects the likelihood of being in an accident. Use a significance level of 0.01. So we have 3 colors, red, blue, white, and accident and no accident. So we want to know if they are dependent or independent, the color of the car and the being in accident or the number of accidents. So one more time here, HO I put they are independent, H1 dependent, degrees of freedom, number of rows 2 minus 1 times number of columns minus 1, 3 minus 1, so it's 2 in this case. So the critical value, again, you can go to the chi-square table and find that value. Let's see if we can get that. So we have, let's see here, 0.01 and degrees of freedom 2. 0.01 is here, degrees of freedom 2, it's here, so it's 9.210. So 9.210. To calculate the test statistics, same thing, second function, matrix, then scroll to edit. Pick here, it's not 2 by 2, but it's 2 by 3. Enter the data, then stat, again, test, chi-square test. So if you calculate, you get 0.4207. 0.4207, I put it here, it's in the non-shaded region. So fail to reject HO, that means accept HO and accept the fact they are independent. So the color of the car and the number of accidents are not are independent. So you can write that. The solution, we have it, let me read that for you. Failed to reject the null hypothesis. There's not sufficient evidence to warrant the rejection of the claim that the car color being in accident are independent, which is the same thing. Number 9, goodness of fit. So this is a goodness of fit problem. Let's read it. In studying the occurrence of genetic characteristics, the following sample data were obtained. At the 0.05 significance level, test the claim that the characteristics occur with the same frequency. So now whatever you're given in the table, these are the observed values. So if you add the observed values, so the total is going to give you 228. Let's remember that. Now, what's the expected value? The expected value is 1/6. We have 6 of them. 1, 2, 3, 4, 5, 6. 1/6 of the total of the observed frequencies. So it's going to be 38. So I made another table here. We have the observed frequencies and the expected one are 38 for each one of them. How can you write the claim? You can write the claim as PA equals to PB equals to PC equals to ... PF, and that should be 1/6. And H1 at least 1 is different. So this is a perfect way of writing the claim. Now we're going to check the solution, which says the same thing, it's just in a different way. Degrees of freedom here is number of categories minus 1. 1, 2, 3, 4, 5, 6. We have 6 categories. Minus 1 is 5. So now the test statistics is the same, is the sum of O minus E squared divided by E. So you have to do it for each one of them. That's pretty long, but you can use your calculator. With calculator, you go to stat, edit, put the O's in L1 and E's in L2, then go to stat, but this time you go to chi-square GOF test, and the calculator will give you the test statistics. And let me do this one too for you, so you can see how it works with the calculator. The only thing here, you need to calculate the expected values. So let's go to, let's go to stat, edit first, because we have to put the data. Let me clear those lists. So in L1, we put the observed values, which are 28. So 28, and we have 30, then we have 45, then we have 48, then we have 38, then we have 39, and in L2 we put the expected ones, which is 38 for all of them. 38, 38, 38, 38, and 38. So let me just double check. 28, 30, 45, 48, 38, 39, that's right. And once it's entered, you go to stat again, test, you scroll down. This is a goodness of fit test. There we go, D. So you enter that, double check observed values are in L1, expected one are in L2, degrees of freedom. Here you have to change it, and sometimes it's not the same, so change it. Degrees of freedom here was 6 minus 1, number of categories minus 1, which is 5, and you calculate. So test statistics is 8.26, and p-value is given also 0.14231, and so on. So let's go make the conclusion. So we found, let's see here, 8.11.71 was the critical value. Again, this is from the table. And then 8.263 is before 11.071. And again, remember, this starts from 0 chi-square values. They're always positive. So let me put 0 here for you to remember. So it's in the non-shaded area. First conclusion, failed to reject HO. Therefore, you can say the frequencies are the same. Or you can write this PA equals to PB dot 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 equals to PF. So let me read the solution for you. The proportion of occurrence are equal. I just wrote one by one. Those proportions are not equal, and I said at least one is different. Test statistics, we got it. That's from the table. Failed to reject the null hypothesis. There is not sufficient evidence to warrant the rejection of the claim that the characteristic occur with the same frequency. So let's see, I said failed to reject. So we are gonna, no, we said failed to reject. So we accept that and we reject that. So we said, then we said a recall, and here it says there is not sufficient evidence to warrant the rejection that they are equal. So if there is not sufficient evidence to warrant the rejection, that means we accept that. So it's the same conclusion. And again, 11.07, I think by now you know that. So you go 0.05 degrees of freedom 5. And let's see if this table, part of this table has it. 0.05 degrees of freedom 5. It's right here. So that's the number. Again, 11.071. Number 10, among the 4 northwestern states, Washington has 51% of the total population. Oregon has 30%. Idaho has 11%, and Montana has 8%. A market researcher selects a sample of 1,000 subjects with 450 in Washington, 340 in Oregon, 150 in Idaho, and 60 in Montana. At the 0.05 significance level, test the claim that the sample of 1,000 subjects has a distribution that agrees with the distribution of the state population. Basically, these researchers picked 1,000 people, and he wants to know if the proportions are the same as given by the state. So that's what he wants to check. Here, HO, you write P Washington is 51%, P Oregon is 0.3 or 30%, P Idaho is 11% or 0.11, and P Montana is 0.08. So you write them separately. Here it doesn't say they are the same, but we know these are the given information. And of course, H1 you can write at least one is different. So if you want the degrees of freedom, you have 4 states. 4 minus 1 is 3. Now you have to calculate the expected frequencies of the researcher. Researcher picked 51% of 1,000 is 510, and 30% of 1,000 is 300, and Oregon is 30% of 1 is 300, and Idaho is 11%, which is 110, and Montana is 0.08% of 1,000, which is 80. The observed value for the researcher was 450, 340, 150, and 60, respectively. Washington, Oregon, Idaho, and Montana. The expected value, you calculate them from the given percentages, and they are 510, 300, 110, and 80. Again, you can do the formula, or for the test statistics, chi-squared is sum of O minus E squared divided by E, 1 by 1, and add them. Or calculator, go to stat, edit, put O's in L1 and E's in L2, then go to stat again, pick D, which is chi-squared, goodness of fit test, and you can find the test statistics, which is 39.938. So it's in the shaded region because it's after 7.815. So first conclusion, reject HO. So we are rejecting that this, so the percentages. So according to the researchers, these are not the percentages with the given sample that he has. So, or you can say at least one is different for the final conclusion. Let's check the solution. The distribution of the sample agrees with the population distribution, which the proportions are either equal. And the second one, it does not agree. So the test is verified. Let's just read the solution. Reject the null hypothesis. There is sufficient evidence to warrant the rejection of the claim that the distribution of the sample agrees with the distribution of the state population. So, which is the same thing. They're not the same. So, number 11, using the data below at 0.05 significance level, test the claim that the responses occur with percentages of 15, 20, 25, 25, 15 respectively. So these are the observed frequencies you give, and that's what we have. The expected ones, you can say 15% of the total. The total here is 80. 15% of 80 is 0.15 times 80 is 12. 0.20 times 80 is 16. 0.25 times 80 is 20. 0.25 times 80 is 20 again. And finally, 0.15 of AD is 12. So that's how you calculate them. And I put the answers here for you so we can take this out. So let's write the claim. PA is 0.15 because it's given in the 15%. PB is 0.20, PC is 0.25, PD is 0.25, and PE is 0.15. You can completely write this, and for each one, write at least one is different. Write tell chi-square test again. So 0.05 degree, 0.05 alpha and degrees of freedom. Here we have 1, 2, 3, 4, 5. 5 minus 1, which is going to be 4. So you can let me put the degrees of freedom. So if you go to the table, 0.05 degrees of freedom 4. Let's go check. I think we can do that again. Here's the table, 0.05 degrees of freedom 4. It's right here, 9.488. So well, let's double check this again. 7. Oh, it's the next problem. There we go. 9.488. So it was correct. So calculator again, stat edit O's in L1, E's in L2. Then go stat, then pick chi-square goodness of fit test. Then if you do that, the calculator will give you the test statistics, which is 5.146. And non-shaded region failed to reject HO. That means we are accepting that they are the same. So, and again, define the proportions are as stated. You can write that, or let's read the conclusion. So what we have failed to reject the null hypothesis, there is not enough evidence to warrant the rejection of the claim that the responses occur according to state percentages. So that's the answer, which is exactly what we said. Number 12, in studying the responses of multiple choice test question, the following sample data were obtained. At 0.05 significance level, test the claim that the responses occur with the same frequency. So this is pretty similar of what we did. Again, you have A, B, C, D, E, 5 subjects. Observed frequencies are 12, 15, 16, 18, and 19. Expected ones, it has to be the sum of that divided by, since we have 5, it's 1/5. So let me just write this. PA equals to PB equals to PC equals to PD equals to P, and that's equals to 1/5 because we have 5 of them here. And each one, at least one is different. If you want to calculate the expected ones, the sum is 80, so it's going to be 1/5 of 80 for each of them. So it's 16 here for all of them. And I put that here. Degrees of freedom, we already know is 5 minus 1, which is 4. And if you want to find the test statistics, again, go to stat, edit O's in L1, E's in L2, then go back to stat, then pick chi-square goodness of fit test. And the calculator will give you that test statistics. Critical value, again, same thing, 0.05 degrees of freedom 4. Go to the table and you find 9.488. Test statistics is in the non-shaded region, so fail to reject HO, and you can write all proportions are the same. And you can read the conclusion, which is the same thing, just worded a little bit different. And 12 was the last problem. Same thing, please, once you finish watching this, just redo the test without looking at the solution, and you can double check your answer, and if needed, watch these 2-3 times or more, then you're going to get very comfortable with these problems. All right, thank you, and I'll see you soon. Bye-bye.